Hello everyone, today in this video we are going to talk about working of a transformer. So let's understand what is a transformer first. So in our domestic circuit we get 220 volt of alternating voltage, but to charge our cell phone we need 5 volt, but to charge our cell phone we need only 5 volt. So we need to reduce this 220 volt into 5 volt. So this 220 volt is converted into 5 volt by a transformer. So the name itself is saying the definition, transform, to transform one voltage into another voltage. Transformer is an electrical device to convert one voltage into another voltage. So when we change the voltage, the current also changes. So working principle, it works on the principle of mutual induction, which means if you change the current through one coil, the magnetic flux through another coil changes, and the change in magnetic flux through this coil gives an induced EMF. So we give one alternating voltage in input side and we get another induced voltage from another side. So it is a application of mutual induction between two coils. So there are two types of transformer. One is step up transformer. So the transformer which converts low voltage into high voltage is called step up, and in step up transformer we have less number of turns in input side and we have large number of turns in output side. Another transformer is called step down transformer, and this transformer converts high voltage into low voltage, and in this transformer we have more turns in input side and less turn in output side. So you can compare these two. This is step up and this is step down. So now let's talk about the construction. So a transformer consists of a core which is made out of soft iron, and this soft iron core is laminated to reduce the eddy current. And this side we have primary coil and we call it input coil, and this side we have another coil, we call it secondary coil, and we give AC input to this coil, that is primary coil, and we get the output from secondary coil. So now let's understand the working. So in a transformer we give AC through primary coil. So when we give the AC, the current through this coil changes, and due to which a changing magnetic field is produced, and this magnetic field changes the flux through this coil, and when the flux through this coil changes, an induced EMF is produced. So by giving some input we get the output. So this is the working of a transformer, and it works on the principle of mutual induction between two coils. So now let's understand the theory. Suppose I am giving AC E through the primary coil, and due to the self induction an induced EMF E1 is being produced in the opposite direction. We know according to Lenz's law the induced EMF opposes the cause, and cause is the changing AC. And suppose V is the voltage across the primary coil. The flux through this changes and EMF E2 is produced. So there is no input, so we have only one EMF, that is E2, but this side we have two EMF. One is input EMF and another is induced EMF. And suppose E is the alternating voltage which we are giving to the primary coil, and E1 is the induced EMF in coil number 1, N1 is the number of turns in coil number 1, E2 is the EMF produced in coil number 2, and N2 is the number of turns in coil number 2. So if phi is the flux through the coils, then according to Faraday's law I can write EMF produced in coil number 1 is given by E1 is equal to minus N1 d phi upon dt. Similarly, EMF produced in coil number 2 is E2 is equal to minus N2 d phi upon dt. So if you divide equation 2 by equation 1, then you will get E2 by E1 is equal to N2 by N1. Other things get cancelled. So now in primary coil we are giving the input EMF as E, and we are getting the induced EMF E1, and these two will try to oppose each other, and total voltage through this coil is V. So we can write the EMF minus the produced EMF is equal to total potential across the coil. So from the figure you can see V is the voltage across this coil, so this minus this is equal to this voltage. So now I'll put the value. If I is the current, then V is equal to IR. So the resistance of the coil is low. So as we are using the copper wire only, so R will be 0. So if you put R is equal to 0, this term will become 0. So you will get E is equal to E1, and your input voltage will be equal to E, that will be is equal to E1. So input voltage is E, that is equal to E1. And in coil number 2 we have only E2, there is no input, so we have only output. So we can directly write there is no applied voltage in secondary coil, so our output will be equal to E2. Now I can write E out by E in is equal to E2 by E1. So our E out is E2 and our E in is E1. So instead of E out and E in, I can write E2 by E1, and E2 by E1 is equal to N2 by N1. So the output voltage by input voltage is equal to number of turns in secondary coil by number of turns in primary coil. So this is the final expression, and this is very important expression. Now the ratio N2 by N1 is called transformation ratio. If this N2 is greater than N1, then we can write N2 by N1 is greater than 1, because larger number divided by small number. So this time we will get E out. E2 will be greater than E in, and if E out is greater than E in, that time we call it step up transformer, because we are giving small voltage and we are getting large voltage. So the transformer will be called step up transformer. Now if N2 is less than N1, then we can write N2 by N1 is less than 1. E out will be less than E in. That time our transformer will be step down, because we are giving the large input and we are getting the less output. Now let's find the relation between input current and output current. So as the energy is conserved, so we will not get extra energy from the transformer. Whatever energy will give, that same energy will come out of the transformer. So input power is equal to the output power. So we can write P input is equal to P output, and formula for power is V into I. So I can write E1 I1. So potential is E out here. So similarly here I can write E2 I2. So for output we are using 2, and for input we are using 1. So if you take this down out here, E1 by E2 will be I2 by I1. So now E2 by E1 is N2 by N1. So E1 by E2 will be N1 by N2. So I can put the value. So I'll get I2 by I1 is equal to N1 by N2. So this is the relationship between input and output current. So in transformer we can increase the voltage, but we do not get extra energy from the transformer, because the law of conservation of energy is there. So if you are converting 10 volt into 1000 volt, so whatever work is done by this 10 volt in 1 hour will be done by this 1000 volt in 1 hour only. So there is no change in energy, but only we are changing the voltage. In transformer there are some types of loss in energy. So these losses are copper loss. We all know the conductor produces heat energy due to the heating effect of current. So when current flows through the copper, the heat is produced and some energy is lost, and that loss is called copper loss. Second loss is called eddy current loss. So we know when the magnetic flux through the core changes, there will be production of eddy current, and that eddy current produces heat, and which is again lost from the transformer. And third one is flux leakage. So whatever flux is produced in primary coil will not go to the secondary coil. Some of the flux will get leaked into the atmosphere or air, and all the flux will not go to this primary, and this loss is called flux leakage. And the third one is humming loss. So when we use the transformer, it produces humming sound, and this sound is produced due to the change in length of the core while passing the AC through the transformer. And these are the uses of transformer. So it is used in electronic appliances. One of the example is our mobile phone charger. It converts 220 volt into 5 volt. And another example is power regulator, which we use in TV and fridges. And the third one is power transmission. So to transmit electrical energy from one point to another point, we make use of transformer. So in next video we'll talk about the transformer in power transmission. So this is the end of the video. Please don't forget to like the video and subscribe the channel. Thank you.